Hi, I'm Anthony Stefano, and this is my final presentation for SDR520. And throughout this little presentation, I'll be going through a brief intro to the three lab challenges that we went through throughout the semester, how we solved them, our methodologies behind it, as well as some challenges that we went through, how we solved them, or maybe the challenge that we didn't solve, how we maybe could have solved them, like the resources we could have used, as well as the main learning outcomes that I've learned throughout these lab challenges and throughout the course in general. So I really hope you enjoy it. So to start off, I'll be going through each of the three lab challenges that we did throughout the semester, and I will go through a brief introduction on each of them and explain a little bit of our methodology behind it. So with the first lab, it was mainly a very intro, beginner-based lab that got us to know the ins and outs of ROS and AWS in general, as well as how to bundle a robot application and simulation, publish it to a bucket, and be able to observe as well as modify it however way we can. As for the next two labs, labs 2 and 3, those involved cloning a GitHub repository from the internet onto our ROS development environment. And once we did that, we were tasked to split up the simulations into two parts, one being for mapping and another being for navigation. And so lab 2 was about the mapping portion, and that involved using a controller distributed by the same GitHub to maneuver the robot in an arena around the entire arena to scan that arena and its environment in order to create a map that it can use for later in the navigation to properly maneuver around from one point to another. And yes, with lab 3, we were able to grab that map that we created in lab 2, like I mentioned before, and able to use that map in a similar looking arena, only this arena in lab 3 has dynamic moving objects around that the robot has to know to avoid, and we use that same controller from lab 2, and we were able to set a certain coordinate along the arena or the map that we created and have the robot just kind of navigate towards that spot and be able to know to stop or watch out for moving objects as well as walls and know how to maneuver itself around appropriately. And now with those intros out of the way, let's get to discussing the problems me and my partner may have faced during developing and completing these lab challenges, as well as how the solution to how we solve them, or maybe how we didn't solve them, and how we could have, or the resources that we could have used to solve that problem. And with the first challenge that comes to my mind, I would say it had to be with lab challenge 1, and that problem surfaced from the inability to bundle the robot and simulation applications of the sample Hello World project, and being able to launch that to an S3 bucket and view the results of that. We were unable to get that to work at the start, but to solve that, me and my partner, we asked our professor to help us out, happily able to help us out with that, and so he went into the development environment for our lab challenge 1, and he was able to tweak it in a way and fix certain things so that we were able to bundle the application in the end. And so really thanks to him for that. Really appreciate it. And so for a problem that we couldn't solve, that problem included getting the end result, the right end result of Lab 1, being that the robot, we couldn't really get the robot to move forward for a certain amount of time and then stop. This is because we just didn't really know how to code that or what the proper code for that would look like. And for that, I feel like what we should have done is, again, ask for help from the professor, or maybe do more research online on code on how to do that, as well as maybe ask some of our peers as well. Definitely a lot of options I think we could have used, but in the end it worked out, so that's alright. And now, so for the learning outcomes of the lab challenges, I think the main thing that I've learned throughout these labs is the two main things of autonomous navigation and robotics in general, mapping and navigation. I feel like learning about those two and the little processes that go through each system, of how in mapping when the robot needs to scan its surroundings with various sensors attached to it in order to build a proper map of its environment, and with the navigation of navigating through that environment with even more sensors that can bring information to the robot for it to be able to navigate through different scenarios to get to point A to point B. I thought learning about those was very interesting, and I really enjoyed that a lot. And even things just like with learning about AWS and how ROS works, and the way to set up software like that to build robotic applications such as the ones in labs 1 to 3. I really thought this was a good interesting experience. I never really used these kinds of software before, so it was interesting trying to learn how to tackle them and build interesting applications for them. And now that's going to wrap up this video. So we talked about a brief intro of all the labs and the little ways of how the labs worked and how we implemented them, as well as some challenges that me and my partner faced during these labs, how we may or may not have solved them in various ways, and how we could have solved them if we didn't, as well as what I've learned throughout these lab challenges. I really hope you enjoyed, and thank you for watching.